Today we talk about kinematics. Well, it's not really a major topic anymore, but there are some formulas we need to learn. Okay, there are some formulas we need to learn. Okay, so I'll just list out all the things you need to know for kinematics, and we do one examples for that, and you can just go to do revisions now. This topic should be included in the application of the differentiation, because we have those things, I think, from year 10 or year 11. So we have displacement and distance, they are a pair, and we have velocity and speed, that's a pair, and we have acceleration. Okay, because I think this should be covered in year 11, that's why in the notes it's not really covered everything, not have all the formulas, you need to write some by yourself. So first of all, that's the relationship between them. So displacement, we can represent that by xt function. So velocity time graph, we can use vt to express that, and acceleration, we can use at to talk about it. It's always relate those unit to time. Okay, we talk about when at this time v is what, x is what, and a is what. So it's always xt, vt, and at graph. Okay, so we want to get from xt to vt and vt to at, we do differentiation. Okay, I just write diff. So we do differentiation to make xt become vt and vt become at. That's what we should do. Okay, and also we need to know displacement, velocity, and acceleration. They can be positive or negative. Okay, they can have positive or negative values, because the negative and positive means the direction, whether it's to the right hand side or whether it's to the left hand side. Okay, this motion we talk about in year 12 is only straight line motions. Okay, if I'm walking from here to there and walking back, we keep doing this motion. I'm not going to be walking there and turn somewhere else. I'm not talking about that motion in year 12. So this motion only means straight line motion. Okay, walking back and forward. Okay, then what's displacement and what's distance? I think most of us will know about this, but just in case, I'll just mention that again. We always have origin to talk about. We relate to a point, and normally we say we relate to the origin. And if we relate to the origin, let's say that's a positive 2, negative 2, negative 1, positive 1, and positive 2, and 3, and negative 3. Okay, someone walks in a path, like I start from the 1, I go to 3, go back to 2, and back to 3. And go all the way to negative 3. Okay, that's how this person's walking. Okay, just walking that, going back, forward, and then keep moving all the way back. Okay, that's how this person's walking. So we can see the distance is easy to understand. Okay, distance is all the distance I covered, like from starting point to the finishing point. So in this distance, I walk a 2 unit. I walk 1 unit here, 1 unit here, and I walk 6 units for the long one. So the distance will be 2 plus 1 plus 1 plus 6. That's a 10. So if I said that's in meters, so I have walked 10 meters from T0 to the end point. But if you think about displacement, I compare what I'm standing at the beginning to what I'm standing in the end. So I'm standing at the position of negative 3, but standing at the beginning at the position of 1. I have changed my position for 4 units, but to the left hand side. So it's a negative 4. Okay, it's a negative 4 of the displacement. I don't care what happens in between. I don't care I walk to the right and then back and then left again. So what I use is my final position, which is negative 3, minus the initial position. Okay, it's always the final position minus the initial position. That will gives me minus 4. So minus 4 is the change in the starting position and finishing position. So -3 is my finishing position, 1 is my starting position. I subtract the final minus the starting, give me the total displacement. So basically it's talk about what's the change in my position. I've changed 4 units but to the left hand side. That's my displacement. So this is the difference between the displacement and distance. Okay, that's the difference between the displacement and distance. Now we'll talk about 3 formulas related to this. Okay, the first one is called average velocity. Okay, the next one we talk about is average speed. The last one we talk about is average acceleration. Okay, that's the 3 formulas we need to know. Well, average acceleration is given in the notes. But what's average velocity and what's average speed? Okay, a lot of students get this wrong because when they see average of this thing, they add the 2 velocity and divide that by 2. That's not correct. Okay, so that's a common mistake. Well, average velocity, good, we add 2 and we divide by 2. But that's not right. So average velocity needs to be used to use the change in displacement over the change in time. Okay, change in displacement over the change in time. What that means? Okay, let's say this is when t equals to 0 and this is when t equals to 5. Okay, when t equals to 0 and that's when t equals to 5. I start at t0 and I finish at t5. So during that for 5 seconds, okay, my displacement is a -4. My displacement is a -4. Okay, final minus the starting. So my average velocity for the previous example will be -4/5. Okay, will be a -4/5. Okay, what's the change in time? 5 seconds. What's the change in displacement? -4 units. Okay, -4 units. So it's -4/5. Similarly, what's the average speed? It will be the distance covered over the total time. Well, you can also say it's the change in displacement or distance over the change in time. So in the above example, distance is 10, okay, in 5 seconds. Over 5, that gives me 2. So the distance, the speed is related to distance. So I'll use change in distance, which is 10, over the change in time, which is 5. That gives me 2. Okay, that gives me 2. And then average acceleration. Average acceleration will be very similar. It will be the change in velocity over the change in time. Okay, the final velocity minus the initial velocity over the time. Okay, over the time. So it's for velocity, speed, and acceleration. If we talk about the average of them, we never use that to talk about the average. We always use the thing up in front of that. So velocity is used displacement to do. Speed is used distance to do, and acceleration is using velocity to work out. So it's always the change in the previous amount over the time. Okay, over the time. So that's the 3 formula and very important 3 formulas we need to know for the motion topic. Okay, for the motion topic. So okay, what we have learned so far, we learned the differentiation between xt, vt, and at, how we can get from each other, and we talk about the average speed, velocity, and acceleration, 3 formulas. And one last thing we need to know is the very useful graph, which is the vt graph. If you have xt, vt, and at, they ask you to select one to only give you one, ask you to select one. I will select the VT because VT can get most informations, okay, it can get most piece of informations. So if we sketch a VT graph, okay, if we sketch a VT graph, I'll give you an example, okay, well, any example will work. So that's the time, that's the velocity. I will start at a velocity of 4. This is 4 as well. Okay, that's my velocity time graph. I have a decreasing velocity. So that's 4. That's 4. So if you see this equation, the VT should gives you minus t plus 4. Okay. That's how I work from the 2 points. The straight line has this equation minus t plus 4. I sub 0 in, I have 4. I sub 4 in, I get 0. So that's the equation. Okay, now I want to talk about t equals to 2 to t equals to 6. What happens in between those periods? Okay, t equals to 2 to t equals to 6. Let's not do 6. Let's go t for 1. Don't want to be symmetrical. So t equals to 1 is here. And t equals to 6 is here. Okay, can you see if I draw the vertical line between the two required time, I can form some area between the graph. Okay, I can form some area between the graph. I can form some area between the actual line, the x-axis, and the vertical line we sketch. I can form right angle triangles here. Why I sketch for the area? Because the area under the curve bound by the time will give you information about distance and displacement. Okay, this area can give us the information about distance and displacement. So let's have a look at when t equals to 1. This is 3. Okay, this is 3. Because you sub 1 into the equation, we get 3. And when it's equals to 6, I will have 2, negative 2. For the vertical, well, for t equals to 6, and velocity will be negative 2. Okay, sub into the equation. This is a substitution. Alright, now let's say this area is A1. Well, this area is A2. Can you see I form some area above the x-axis and also below the x-axis? Let's calculate the two areas first. A1 equals to what? A1 equals to a half base times height. Okay, because the base here is a 3 and the height is a 3 as well. 1 to 4 is a 3 unit and this height is 3. I have calculated out that. So that's a 9 over 2. And if you think about A2, A2 is a half times base, which is 2 here, 4 to 6, and times another 2, which is the height. Okay, we have calculated the height here, which is 2 units. Don't talk about the negative yet, we just times this. And we have 2. Okay, the area for that one is 2. Okay, in between t equals to 1 to t equals to 6, I want to know the total distance covered. Okay, I know the total distance. Distance is always positive. Okay, it's always positive. So we will just add the two areas. Okay, we will just add the two areas. That gives me a 13 over 2. When I add the two areas, that will give me the distance. Okay, it will give me the distance. When we talk about the displacement using the same two areas, I use the top area to subtract the bottom area. Okay, the top one, you know displacement is with positive and negative. So the area below the x-axis will be negative, and the area above the x-axis will be positive. So the positive minus the negative will give you the distance. So displacement, the displacement 4, that's a 4, that's a 5. So the displacement in between 1 second to 6 seconds will be a positive 5/2. It will be a positive 5/2. So why I said VT graph is very useful, because that can also give me information in between any point of time. Talk about the displacement and talk about the distance. Any questions? That's all the things we need to know for the motion topic. So first thing we need to know is the xt, vt, and at graph, how to get from each other. We differentiate xt, get vt, we differentiate vt to get at. And the second thing is the three formulas: average velocity, speed, and acceleration. And the third thing we need to know is the vt graph. Okay, it's the vt graph. What vt graph can give me in between the 2 points? So in between any 2 points, I can form area. The top area minus the bottom area will give us the displacement. But if we add all the area together, that will just give me the distance. Okay, so that's everything we need to know for the motion. After you know this, can you go to example 1? Let's have a look at example 1. Let's talk about all the things we talked about so far. Okay, so for example 1, we get a particle moves in straight line, okay, straight line motions, so that its position x centimeter relative to O at time t seconds is given by xt equals to t squared minus 7t plus 6 when t is greater or equals to 0. Okay, for this question, I can immediately to find the vt. Vt is 2t minus 7. Also, at the same time, I can find at. At will just be a 2, because at is a uniform acceleration. Okay, it's a uniform acceleration. We find at. Because we did vt, we got 2 only. Okay, we got 2 only. So what we can find from that now is find its initial position. Well, initial position is talk about x. So initial means when t equals to 0. When t equals to 0, we have 6. Okay, it's on the positive side of the origin of 6 unit. Okay, positive side of origin of 6 unit. Find its position at t equals to 4. So we talk about t4. So it's 16 minus 28 plus a 6. That gives me negative 6. That gives me negative 6. So that's the t equals to 4 was the position. It's on the negative side of 6 unit. Okay, of 6 unit at t equals to 4. Okay, find its initial velocity. Initial velocity is v0. Okay, it's v0. That is just a minus 7. That is just a minus 7. When does its velocity equal to 0, and what is position at that time? Okay, when is velocity equals to 0 and what is the position? So we want 2t minus 7 to be 0. That gives me t equals to 7 over 2. That gives me t equals to 7 over 2. And we have x, okay, asking for position. X 7 over 2, right, smaller here. X 7 over 2 equals to 49 over 4 minus 49 over 2 and plus the 6. Okay, plus the 6. And I know that is minus 49 over 4 plus a 24 over 4. That gives me minus 25 over 4. That's the position when the velocity equals to 0. And that is at t equals to 3.5 seconds. At t equals to 3.5 seconds. Okay, it's all easy here. Okay, it's all basic substitutions. It's all basic substitutions. Okay, now we have done the differentiation, we have done substitution, and the next question is asking for formulas. What's the average velocity for the first 4 seconds? Okay, first 4 is t equals to 0 to t equals to 4. Okay, for the first 4 seconds, t equals to 0 to t equals to 4. So average velocity equals to the change in position. Change in position. At the final time, my position is minus 6. And at t equals to 0, my initial position 6. That's the answer you get from A and B. Okay, that's the final position minus the initial position over the change in time, which is 4 seconds. Or if you want to do, you can go 4 minus 0. That's a minus 12 over 4. That gets a minus 3. Okay, minus 12 over 4. That gets a minus 3. So the average velocity is towards the negative side of 3 centimeters per second. Okay, towards the left-hand side for 3 centimeters per second. Okay, change in displacement is easy to find. Okay, change of displacement is easy to find. But the next question is asking us, determine its average speed for the first 4 seconds. Okay, I want to know information about the speed. I need to know the information about the distance. But I only got xt graph. It's hard to get the distance. Okay, you can, but it's hard to get the distance. What we can do now is, what I need is the distance covered in 0 to 4 seconds. Okay, that's what I need. It's in between 0 to 4 seconds. So what I can use is the Beatty graph. Remember, if I add the area under the curve, that will give me the distance. So I can use the Beatty graph. So when t equals to 0, we got negative 7. And that is when t equals to 7 over 2, because it's when the velocity equals to 0. We work out that in the previous 2 questions, and we draw the line here. That is the Vt graph. So Vt equals to 2t minus 7. Also, I know here is a minus 7. This is 7 over 2. Because I need information between 0 seconds to 4 seconds, so I will have the 4 here, which is 2 over 8. It's 0.5 seconds in between 0 back to that. So 0 to 4 seconds, I need to draw vertical lines to it to form area. Okay, that's the area formed. That's the area formed as well. So in between 0 seconds to 4 seconds, that's the area bound by the curve. Okay, that's the area bound by the curve. Also, when t equals to 4, this height is 1. Okay, this height is 1 because I sub V4 in, that gives me 1. So I have a height of 1. I can still say this is A1, the larger one is A1, and the smaller one is A2. A1 equals to what? A1 equals to a half times 7/2 times 7. Okay, base is here to here, which is 7/2, and the height is a 7. So I got 49/4. A2 is what? A2 is a half times 1. Okay, that's a half. That is 1. Okay, that is half. That is 1. So that's a half times 1. That gives me a quarter. Now, distance. Okay, for t equals to 0 to t equals to 4. What's the distance covered? If you talk about distance covered, it will be the total area. So it's 49/4 plus a quarter. So it's all the area bound by the curve. Okay, it's all the area bound by the curve. So that gives me 50/4, and that's 25/2. Why I need this? Remember, I want to find the average velocity, right? Average speed. So I need to know the total distance covered. So I know the distance now. Average speed equals to 25/4 divided by over 2. Sorry, that's over 2, and that's over 4 seconds. Okay, so the total distance covered in 4 seconds is 25/2, and divided by the time. So that's a 25/8. Okay, times by a quarter, that is 25/8. Yes? Yes, it's, well, you know, like VC exam is not really looking for units. It's okay not to put units, but because also for this one, I don't think I don't put units for the time and also not putting for the x, so I don't know what's the unit. It will be, it can be second, can be minute for the time. Do you have it? Second, t seconds are centimeters, so I can put that. So centimeters, well, the speed will be centimeters per second. I can put on that, but you won't lose mark because of the unit. So that's why we encourage students not to put unit, because if you put wrong unit, it can be wrong. So we encourage not to put unit, it's alright. But if you're confident with that, just put it on. So that's the average speed. Okay, we also can think about the displacement. We can also think about displacement by this graph, okay, and compare with our answer before. So the displacement will be the top area, which is a quarter, minus the bottom area, which is 49/4. That gives me minus 48/4, and that's a minus 12 centimeters. Which is exactly the same as the minus 6, right? And we can write average velocity equals to minus 12/4, and that gives me the same thing, minus 3 centimeters per second. That's exactly the same as the question on the left hand side. Just make it smaller. Okay, we can use the VT diagram to help us to find out the area under the curve in order to find the total distance and the change in displacement, and also the change in displacement. Just wants to add one more thing to cover everything we have learned. talk about what is the average acceleration for the first 4 seconds. Okay, what's the average acceleration for the first 4 seconds? Two. Okay. Average acceleration equals to the v4 minus v0, the change in velocity over the change in time. So remember, v4 equals to 1 and v0 equals to minus 7. Over the 4, we get 2 centimeter per second square. Okay, per length unit per time square. That's the unit for acceleration. And that's the time for acceleration. The unit for the distance and per time square. If it's hour square. If it's minute square. But normally we have meter per second square or centimeter per second square. Okay, that's just use of the formula. How to find average speed, average velocity, average acceleration. How we can use the Beatty graph to help us to work out the distance and displacement. And how we use differentiation to find from xt to vt and vt to at. Okay, so if you can do this question, that's all fine. Okay, we have covered everything so far. You can use the rest of time to finish example 2 and example 3, and you can check answer with me later. And that's the end of chapter 10. Okay, we can do revisions now. Okay, we can start doing revisions now. Prepare for the set.